This question is from NEST 2008. For a concave mirror of radius of curvature r, a ray parallel to the axis but far from it, that is not satisfying the paraxial ray approximation, on reflection intersects the axis at f prime. If the distance between the pole of the mirror and the point f dash is denoted by small f dash, then small f dash is less than r by 2, equal to r by 2, f dash is in between r by 2 and r, f dash is equal to r. Acha. So which type of mirror is it? Concave mirror, radius of curvature r. Now here we are having a ray which is not satisfying the paraxial ray approximation. So first of all you need to know what paraxial approximation is, right? So suppose this is our mirror, concave mirror, okay? Suppose this is its axis, okay? Let this be the pole, and suppose this is its center of curvature, so Cp will be equal to r, okay? Cp will be equal to capital R. Now look, there is a ray which is parallel to the axis, okay? So the ray is parallel to the axis, but far from it means what? Look, if we drop a perpendicular from the ray on the axis, okay, where the ray meets the mirror, okay, we would usually, let's call this point as n, point of incidence, okay, under paraxial approximation, we consider n to be coincident with p. Okay, so we consider length np to be 0, but that is not true. Only when the rays are very close, then we can use that approximation with reasonable accuracy. But if they are saying that it is not valid, that means the gap np is significant and we cannot ignore it. Okay, we cannot ignore it. That's the meaning of this this problem. Okay, that is not satisfying the paraxial ray approximation. Okay, okay. But of course, the laws of reflection will get obeyed. So suppose this is our normal. We know it's a spherical mirror, right? So what will happen after reflection? After reflection, this particular ray will find a path, making sure that angle of incidence, okay, angle of incidence is equal to angle of reflection, okay? And then they are saying that after reflection it intersects the axis at f dash. So this is f dash, okay, this is f dash. They are saying if the distance between the pole of the mirror and the point f dash is denoted by small f dash, okay? So f dash p is f dash, okay? That's what they have given. And we now have to decide whether f dash is less than r by 2, equal to r by 2 and all that. Look, normally we would select option B, under paraxial approximation. Correct. Under paraxial approximation we would select option B. But we can't select option B now because we cannot consider n to be coincident with P. So how to deal with it? This is now a pure geometry problem. Okay, this is now a pure geometry problem. Look now, let us first consider triangle CMN. Okay, let us first consider triangle CMN. What will be this angle? This angle will also be theta, okay, because this is parallel to axis, so alternate angles. Okay, so can we get an expression for sine theta from that? Yes. What is sine theta? Sine theta will be opposite side mn upon hypotenuse, that is r. Okay, sine theta is equal to mn upon hypotenuse, that is radius cm. Okay, now look, can I say that this angle is 2 theta? Which angle? M f prime n? Yes, because this time if I consider this as my transversal, the reflected ray, then obviously the angle made by that ray with the horizontal will be 2 theta. Is it clear? Because this angle is 2 theta. Yes? Did you understand that? Okay. Now consider triangle. F prime mn. Tell me what is sine 2 theta. What is sine 2 theta? Sine 2 theta will be mn upon f prime n. Raise your hands if you understand that. Sine 2 theta is mn upon f prime. Okay. Now look, what we can do is, we can say that sine 2 theta is equal to what is going to be mn? Can I write mn as r sine theta? Of course I can write it as r sine theta. And now let us keep f prime m as it is for this step. But because triangle CF prime m is isosceles, since triangle CF prime m is isosceles, okay, because triangle CF prime m is isosceles, f prime m can be written as CF prime. Okay, let's write it then. Also let us make use of the fact that sine 2 theta is 2 sine theta cos theta. So 2 sine theta cos theta is r sine theta upon what is f prime m, CF prime. So sine theta goes, what is CF prime? CF prime is equal to r by 2 cos theta or r by 2 into sec theta. Okay, got it? R by 2 sec theta. Okay. Now we have to decide whether that small f prime is greater than or less than r by 2. What is Cp? Can I say that Cp is equal to Cf prime plus f prime p? Yes. Cp is equal to Cf prime plus f prime p. Cp is r. Cf prime is r by 2 sec theta. This is f prime. So what is f prime? Okay, look, now instead of continuing and arriving at the final result using inequalities, tell me if I can write this. Because sec theta is always greater than 1 in this case, because theta is not equal to 0. Okay, r by 2 sec theta will be greater than r by 2. Okay, so definitely f prime has to be less than r by 2. Is this argument clear? Cf prime is r by 2 sec theta. Okay, r by 2 sec theta, but sec theta is greater than 1. That means the first term is contributing more than half of r, which means the second term must contribute less than half of r. So f prime is less than r by 2. F prime is less than r by 2, that is option A.